Hi, welcome to the exam collection. So we've got a new video with another 6 questions to help you prepare for your GCSE calculator paper. If it's your first video with us, it's really, really simple. We literally go through 6 questions, you pause, you have a go, and then you look at a work solution. It's a really nice, short, snappy addition to the revision that you would be doing. All right, so without further ado, hit that pause button and have a go at this question. Okay, so gradient is all we're actually being asked here. So that's our key word. The gradient is found by looking at the rise over the run. Now, that is basically a vertical and horizontal movement around the line. I'll show you what I mean. So if I'm going to make a right angled triangle, I am going to choose a position on this line to start. Now, I always go to where it crosses because it generally crosses in a perfect corner here, look. Now, if I travel along this line, it doesn't go back into a perfect corner. So there's the perfect corner of a square with the line going right through it until you're here. So those are the 2 points that I mark. They're the diagonal of this right angle that I'm going to make. So this horizontal movement across is my run, and that movement is my rise. And then it's just a case of seeing what that is. So you don't just count squares. In this case, it does work, but it doesn't always. Just check your scale and make sure what that distance is. It is a distance of 2. So my run is 2. My rise is going from 3 to 6, which is a distance of 3. And that is it. That's the answer. You don't actually have to do any more. You can change it into a decimal if you want to, but you don't have to. That is the gradient of that line, and that's all we've been asked to do. Okay, next question. Hit pause, press play when you're ready. Okay, so I hope that helped, because we often forget this, and I think it's really, really important to not be reminded of it after, but for a change, be reminded of it at the beginning. So I hope you did make points about why you were doing what you were doing. So when it comes to these types of diagrams, it's really, really important that you just take a minute to think, right, what am I looking at? And what do I know? Those 2 questions will help you retrieve knowledge. So they're really critical questions to be asking yourself. So when I look at this, I am looking at an isosceles triangle. I can see that here with those lines. I can see a second triangle here. When I look at the X that they want from me, I can see that actually if I had D, if I had that value there, I'd be able to use angles around a point. So as with these, you generally can't just work out X straight away. They've given you numbers that are going to help you along the way. So really, I think one of the best ways to do this is to just do anything that you can, and then you bring that answer into your result and you're good to go. So let's just do this. Okay, so I can see an isosceles. Those are the 2 edges, and they are pointing to the 2 angles that are the same. So I know that this angle here and this angle here will be equal. So I'm going to do 180, take away 116, which will give me 64, divide that through by 2 so that I can share them out, and I've got my 32 degrees. Mark it into the diagram, and then remember to give your reason. Do it as you go along. If you do it as you go along, you don't have to think about it again. So I did all of that working out based on the fact that I had an isosceles triangle. So isosceles triangle and the fact that it equals 180. Those 2 things are what enabled that piece of maths. And that's what they want you to write down for your reasons. Now, I have a sneaky little right angle in there, which I know is 90 degrees. So if I do 90 and take away the 32, okay, take away that, it's going to leave me just that little section in the new triangle that I want. So 90 take away 32 is 58. So I've got 58 in this corner of the triangle. I've used right angle equals 90 degrees to help me with that step. Now I'm going to do 180, take away 55, take away 58, take away what you know, and it leaves you what you don't know. So I now know D is 67 degrees, and I used a triangle equals 180 there. And now I can finish it off, can't I? Angles around a point, 360, take away 116, take away that 67. That's going to leave me 177 degrees, which is what my X equals. And that I used around a point. Oops, squeeze it on, equals 360. So X is equal to 177 degrees. All right, next question. Hit pause, press play when you're ready. Okay, so we have similar rectangles. Similar rectangles means that they have been enlarged. They are directly proportional to each other. So if one edge has been multiplied up by 2, the other edge would have been multiplied up by 2. So that's what we're looking at there. We are able to use our boxes and labels. So students that I teach will know what I'm talking about. It's just a way of organizing the numbers. It's not essential to approach it this way necessarily. So I would set up my boxes and labels grid and look for the fact. So there's a connecting fact that will always go side by side in the box. So on my small shape, I've got 6, and that corresponds to the same edge on the large, which is 21. So on the small shape, I've got 6. On the large, I've got 21. On the small, I've got 5. And on the large, I don't have anything. And I need that edge if I'm going to find the area of this large photograph. So there's my trap number. That's the number that is always the one that I divide by. I can put the other 2 either way round. It makes no difference, especially when it's on a calculator paper, because you're only going to pop it in the calculator anyway. That is going to give me 17.5. So I know that that is the edge. Find the area, base times height. So 21 times 17.5 is the last step. And there's your final answer. Okay, next question. Hit pause, press play when you're ready. Okay, so Kathy wants to buy exactly 750 grams and she wants to do this as cheaply as possible. So if we take the large can, which is 300 grams, and add another 300 grams, that gets me to 600. And then all I need is a small 150 grams, and that's going to give me what I need to purchase. So that is 80p plus 80p plus 35p. Okay, and that comes out at £1.95. And that would be the natural thing to do. You buy the biggest because the biggest is generally better value for money. So that's what you're doing. My alarm bell would ring because why is the 200 there if it's not useful? And I would never go with my first attempt. Okay, I'm being drawn into what I feel should be normal and natural. And as a result, I may not check anything else, but it's really, really important that I do, because actually that isn't the cheapest option. Okay, if I do 200 grams and get my 600 that way, oops, I'm going to write 600. Okay. then I'm going to still need 150 grams to get me to my 750. But my 200 grams are not overly expensive. So 45, 45, 45, and 35. This adds up to £1.70, which is actually cheaper. So is it the cheapest, or should I check further? Now, if this was my GCSE exam, I would keep checking. I would exhaust everything to make absolutely sure. So another option would be to buy just the small beans, okay? So if I did 750 and divided that by 150, that would be 5. So I would need 5 tins at 35 pence. That comes out at £1.75. So this is proving to be the cheapest. So work out the cheapest cost, it will be £1.70, and that would be what we put on our dotted line. Okay, so watch for these types of questions. All right, here's a selection of indice questions. Hit pause, press play when you're ready. Okay, so a power to a power requires us to multiply. They're quite small, aren't they? Hopefully you can see them clearly enough. So 3 times 2 is 6. So the answer to this one is p to the 6. All right, next one, we've got T8 to T3. And a division means you take away the powers. So I've got T to the 5. This one up here is a little bit different. It's a multiplication question. What they're doing is testing how confident we are with our knowledge. Now, our knowledge is that you add the powers. So this is really no harder than 3 plus this number I don't know needs to equal 9. So n would be 6. So for something that looks complicated, it's not too bad, is it? Okay, the last one is a solve. It's work out the value of x. So it's really just an equation. So I'm going to write it out. So we've got 2x cubed equals 128. Now, if I want to know what x equals, I'm going to get it on its own. First thing I'm going to do is move this times by 2. It will land as a divide by 2. X cubed is now 128 divided by 2, which is 64. Now, to get x on its own, I need to move this cube. It will land as a cube root. And when I do that, I get my x is equal to 4. Okay, so just make sure you know how to put a cube root into your calculator, because if that came up and then you didn't know where the buttons were, you're going to struggle. So that is, obviously an important skill. We want to be able to use that tool brilliantly. Okay, last question. So if you've watched any of the other videos, you would have seen some sneaky simultaneous equations be in worded questions. This is the other way that we see it. And actually, it's quite common to see it like this. So it's really clear. It says it's simultaneous equations. So they're testing, do you have the knowledge and the skills to answer that question? So hit pause and press play when you're ready to look at the solution. Okay, so the first thing that we're going to do here is get those x's to match. At the moment, I've got a 2x on the first equation and an x on the second. I want them matching. So I'm going to multiply this one up by 2, which is then going to give me 2x minus y equaling 13. That's the top one. I don't need to change that one. And then when I times through the bottom one, I'll end up with 2x, and then double it, I'll get minus 4y, double it, I'll get 22. Okay, now the next step is to take away the x's, take away the y's, take away the numbers. And I would always show those negatives. And the reason that I do it is because of this section here, and sometimes this one as well. But definitely here, we end up with so many signs, it can get really, really confusing. So you can see 2x, take away 2x, well, they're gone. And that's the point of the method, to get rid of the x's so I can just concentrate on the other letter. So I've got minus y. That is what I've got here at the top. and then it says take away -4. This here is creating two negatives, and two negatives make a plus. So I'm actually at -1, minus y, and I'm going to add 4. Okay, adding 4 is going to take me to 3y. And then 13 take away 22 is -9. I want to know what y equals. I'm going to get it on its own. So I'll divide through by the 3, and y is equal to -3. Now I'm going to take that value for y, and I'm going to substitute it back into one of the original equations, and I'm going to use this one. So 2x minus y is equal to 13. 2x, all right, now we've got to be really, really careful here. 2x minus, now I'm going to put the y in, and the y is -3. So -3 equals 13. So write it down as you go. I've got 2, I've got x, I've got minus. Now the y goes in, and I won't lose that, which is obviously critical to getting it right, isn't it? So what I've got now is 2x plus 3 equaling 13. And if I want to know what x is, I'm going to get it on its own. So pick up the +3, lands as take away. I've got 2x equals 10. Pick up the 2, lands as divide by 2. And I've got x equals 5. And that's it. There are 6. So hopefully that went well. I am going to make more. I'm going to try and do as many as I can for you. And there will be some repetition, because actually if you need a little bit more time to practice this, it would be nice to do that, then see another question and hopefully do better. Anyway, I will see you in the next video. Well done today.